Hello, everyone. My name is Donald Rogers. I am a junior in the exercise science program, and today I will be presenting on the influence of the left and right limb on the validity of heart rate variability data collected via photoplethysmography. Heart rate variability is a non-invasive method to characterize autonomic nervous system function. It represents the balance of the sympathetic and parasympathetic branches of the autonomic nervous system, seen in the figure on the right. Sympathetic being more active during stressful states, while parasympathetic being more active during restful states. Heart rate variability is the difference in the length of heartbeat intervals, also known as R-to-R intervals, seen in the figure on the right. lnRMSSD is a time domain HRV metric characterizing the difference of successive R-to-R intervals, and for that reason is a good short-term metric of HRV data collection. A recently validated core-sense finger sensor utilizes photoplethysmography technology as well as a smartphone application to provide a more feasible method of HRV data collection. However, photoplethysmography technology relies on variability of the pulse as opposed to variability of the heart, seen in the figure on the right, and for that reason is subject to known differences in pulse arrival time, vessel status, and blood pressure, which all could contribute to interarm collection differences of HRV. As of now, there is no standard procedure on which limb to place the PPG sensor. Thus, the purpose of the study was to determine the left and right limb validity of the PPG sensor device for collecting lnRMSSD HRV data. 20 participants were included in the study, and 5 minutes of lnRMSSD data were collected in both the seated and supine positions. 2 core-sense finger sensors were placed on the left and right, most distal finger of the left and right limb, and these were both validated against a polar H10 heart rate monitor that went around the participant's chest. To examine for differences between the left finger sensor and heart rate monitor, as well as the right finger sensor and heart rate monitor, pair t-tests were used, and to determine the magnitude of these differences, Hedges GFX sizes were also used. In addition, bivariate correlations examined for any relationship between either finger sensor and the heart rate monitor, and interpretations for those are shown on the right. Statistically significant differences were identified between each finger sensor and the heart rate monitor in both positions. However, these differences were considered small in magnitude. Very strong to near perfect correlations were observed between devices in the seated position, while only strong to very strong correlations were observed between devices in the supine position. Thus, there was a negligible influence of limb side, and greater validity was observed in the seated position as opposed to the supine position. Thus, future research should examine more diverse and bigger sample populations, the underlying physiological mechanism behind the found results, as well as any potential differences between limbs. Finally, I would like to thank my faculty mentor, Dr. David J. Cornell, as well as my research collaborators for all their help on this project. Thank you.